Alright, so in tonight's lesson, we'll be talking about quadratic equations. Alright, so in the last class, we actually talked about circular theorem, but in this lesson, we'll be doing a little bit more on algebra, and this time we're talking about our quadratics. Now, as you see here, this is actually saying an equation, and we have to understand an equation. Equations and expressions are different, and where in my previous lessons we talked about expressions, for example, like you have a trinomial being written as 2x squared plus 5x minus 3. We say that this is actually an expression, right? And this can actually be solved by using just the trinomial, the method of just the trinomials. However, we're talking about equations now, and equations means that our expressions are now going to be written with the equal sign, right? So we actually have 2x squared plus 5x minus 3 equals 0. Now, I just want to have a further clarity on if the term quadratic that is written here is that anytime we're talking about quad, like quadrilateral, right? We're talking about like, for example, like four-sided or squares. So what you'll find out is that the highest power index in this equation is actually your squares, right? And that's the idea of really of of your quadrilaterals, right? So, just a moment, just checking my camera, ensure that it is mirrored correctly so we can see what's there. All right. So 2x squared, the square is actually the highest index in a quadratic equation because a quad is really referring to like your squares or four sides. And if you were to write out this expression, it would actually be simplified into, well, basically you're going to actually have four terms, right? So if we want to look at it this way, where we were to just multiply 2 and 3, and we would actually get, and it's actually a negative 3, we would actually get a negative 6 right there, right? Now the other thing is that we need to list the factors of 6, which will be 1 and 6, and we have 2 and 3. And the idea is that we need to get positive 5. The only way to get a negative when multiplying is to have one positive and one negative. Because if both of them were negatives, we would actually get a positive. And if one is up, if both are positive, we're also going to get a positive. So in listing the factors of 6, in order for us to get a negative 6, one of the factors must be a positive and the other must be a negative. So if we want to find the factors, now that is going to give me positive 5. If we have positive 6 and negative 1, right, that's actually going to give me 5. But here we see that this either equals 1, or if it was positive 2 minus 3 would be negative 1. So we have to choose the pair of negative 1 and 6. Now in choosing that pair rather, we would actually end up with four terms. So we would have 2x squared, right, plus we said 6x minus x equal minus 3 equals 0, right? If we're going to subtract this, if we were to just factorize this, we're going to actually have 2x right there, x plus 3. And factorizing again, we're going to take out the 1 there, we would have x plus 3 equals 0. If you want to know about factorization, you have to just visit my other videos where I touched on factorization. Okay? So, understanding this now is that we actually going to now group our terms. So 2x minus 1 in one bracket and in the other bracket is x plus 3. Right? So that is now set to 0. And now, using our zero property rule, we know that we can actually find x because the zero property rule says either both of these terms is equal to 0, either 2x minus 1 equals 0, or x plus 3 equals 0. Or both of them may have equal to 0. That is what the zero property rule actually states. Is that when multiplying two numbers or two terms and the product is 0, is either that one of them is equal to 0 or both of them is 0. So it's just something that we need to know as well. So 2x minus 1 equals 0. And in solving for x, I would actually get, well, this tree will understand that negative 1, if we want, we need to remove it to solve x. So we have to add it here. And adding it there, we also have to add it there. So 2x equals 1. Now x therefore equals 1 over 2. Now look here now, we have x plus 3 equals 0, so we need to remove the 3. If we remove it there, we also have to remove it here. So now we have x actually equals to negative 3. So we have two possible answers for x right there. And that is actually the idea of doing an equation. And in an equation, we have the equal sign and we are actually solving for x. Previously, when we were just doing trinomials, we just have this and without any equal sign and a zero, and that would be fine. But now we're actually solving quadratic equations. All right, so that's really just a basic run up on what our quadratic equations really will give us. But there are some basic information even in solving quadratic equations. So there are other forms of quadratics that I would just like to look at before going further into solving these terms. We also see that this term is actually, we see that this also, which is a squared number, and this is also a squared number. In factorizing this with using the same pattern, the same idea, we can actually solve for x. Where we have x minus 25, we could just simply bring this over by subtraction to remove it. So this would be x equals 25, x squared rather. And then we would actually find the square root of x, and we would find the square root of 25, which that means that x equals, and we're going to have plus and or minus 5. Why do I have plus or minus? Now, plus or minus is simply because negative 5 multiplied by negative 5 equals equals 25. And 5 times 5 is the same, equals 25. It's just that in most cases, when we're asked to find the root of a number, we're in just the positive that is really required. But for quadratic equations, it will be required of you to have both the positive and the negative. I'm just gonna do an expansion of the difference of two squares that we wrote up, what we had up here, and we're gonna look further into why having the negative and the positive. So if we were to just go ahead and expand our brackets, or expand this this further, we would actually get, well, since we're doing the difference of two squares, we're gonna have one bracket, one being negative, one being positive. We're gonna have this right there. So again, using the zero property rule, it would mean that x minus 5 equals 0, or x plus 5 equals 0. So x would either equal, we're going to have a positive right here, and if we have it there, we also have to have it there, cancel out. So x equals 5 here again is the same, we have to have a negative 5 here to cancel out the 5. And if it's a negative there, it's also has to be there. So x is going to equal to negative 5. So x again down here, when we expand it, we see that x really has a positive and a negative value. If we were to substitute and put it in here, where we have x squared, if we were to have negative 5 squared minus 25, we would see that it really equals 0 because negative 5 squared is 25 minus 25, and that equals 0. And if it was without the, the negative, it would still be the same. So there are two possible values of x equals 5 or x equals negative 5. All right, let us look at this binomial expression right here, x squared minus 3x. And let us say now we're going to actually have it to be equal to 0. Right? We're going to have it as an equation. Now we could simply go ahead and factor out one of the x. So we have x, and this is what we would have. Using the zero property rule again, we would understand that either that this x right here is 0 for it to equal for this to equal to 0. Either that this x is 0, because 0 multiplied by anything is going to give me 0, or this number right here, when this number right here and this number, when I subtract 3 from x, it also gives me 0. So if x minus 3 equals 0, it means that x in bracket 0 is definitely going to give me 0. So in understanding that, therefore, that the zero property rule is telling us that either x equals 0 or x minus 3 equals 0. So we would have x equals 0, and since it's going to be a positive here, we would also have to have a positive here. So these are cancelled out, and now I have x equals 3. So there you have it. If we were to plug that in, if we say that 0 squared minus 3 times 0, well, obviously, I'm sure you're going to see that to equal to 0. But let us try and work with the 3. Say if we say that 3 squared minus 3, x is also 3 here, equals 0. So 3 squared is 9, and 9 minus 3 times 3 is also 9. 9 minus 0 is going to give me 0. So we can see that there are two possible values for x there again, and we see that it when you if x is 3, it's going to equal to 0, and x if x is negative, sorry, if x is also 3, it's also going to give me 0. So that's just something to have there in mind. All right. So those are just some little basic knowledge or theory behind working with quadratics, right? So there's someone actually asked me if do I have my own school. That's an excellent question. I actually have classes that I teach on Zoom. You can actually email me. Shoot me an email. You can look in the description. I'm gonna put my email there, and you can just email me, and I will get in touch with you for any meeting. Right? So so I actually do private tutoring. All right. So with that now, with that one being accomplished now, we can actually move on to something that is really, really more pressing that I want us to look at. Now, we started out with something, and I'm just going to put it back on the board. So that is actually 2x squared plus 5x minus 3. That's actually equals 0. Right? So if you remember this carefully, we actually got two possible values for x. Right? Now, what I want to do now is that what I want to do is that I want to show you now a deeper look into quadratic equations. So here, as you will know it before, is that a trinomial is written in the form of ax squared plus bx, where we can have our negative here, minus c, right? And this right now is being set to 0. So if we could actually use our trinomial um, how we solve trinomial to actually solve this and then solve for x. But if we were to expand this formula, if we were to expand this formula, we would have we would actually achieve the general formula for quadratic equations. And the general formula for quadratic equation is really x equals minus b plus or minus, and we would have right here we would actually have b squared minus 4ac over 2a. Funny enough that this is really an expansion of that, right? So this is really the general formula for finding quadratic equations. All right, so as we will look here is that this is actually a, this would be your b, this right here would be your c. All right, so any value where anywhere a is, we're going to put 2. Anywhere your b is, we're going to put positive 5, right? Anywhere c is, we're going to put negative c. If you actually were to go back through the video, you will see the answers that we got for here when we just did the trinomial expression and we solved for x. But now we're going to be looking at using our formula, right? So let's go ahead now. So we have x equals negative, and the value for b, so negative, the value for b is actually positive 5. Now we're not putting the x there. So that's plus or minus the square root of b. B is actually 5, so that's actually 5 squared minus 4. A is 2, and c is actually negative 3. All over 2a. A is actually 2. Right? So in writing that out, just to quickly write that out, then ensure that I have enough space down here. So that's going to be negative 5 plus or minus the square root of 25. Negative 4 times 2 is going to give me negative 8. And the negative 8 times negative 3 is going to give me positive 24. And that's all over 2 times 2 is actually 4. Got that? All right. There's more space that we can work with right there. So x equals negative 3, sorry, negative 5 plus or minus the square root of 25 plus 24. So what does that actually give me? Negative 5 plus or minus 25 plus 24 is actually 49. So we have 49 right here. And that's going to be, let me just write it a little bit bigger so that persons can really see what I have right there. That's going to be 49 over 4. All right? So that's 49 over 4 right there. All right. So I'm just going to make some space on the board because I actually put everything in the center. And I could have used this portion of the board, but because I'm also focused on the center, that's why I'm actually lacking space right now. All right. So we have this right here. Just going to erase this as well. And this portion. All right, so working with this that we have now, we have negative 5 plus or minus the square root of 49. The square root of 49 is actually what? Square root of 49 plus or minus would be 7 all over 4. Remember, if you notice we have the plus or minus, we're going to have two values for x, right? X is going to be either a positive or a negative number, right? So here we have actually have x equals negative 5 plus 7 over 4, and we also have x equals to negative 5 minus 7 over 4. So x equals, this is going to be 2 over 4, or x equals, this is going to be negative 12 over 4. You'll get the idea that in most cases, x has either as a positive or a negative value, right? So here now, this would be a half, x equals a half, and here x equals negative 3. Right there. And as I said before, earlier when we did this same question, this one right here, and we actually just went ahead and solved the trinomial, we actually got that x equals a half or x equals negative 3. So using the quadratic formula actually gives me the same answer. But you'll probably ask yourself, why use the quadratic formula when I could just simply go ahead and work through my trinomial and then get two possible answers for x. So we're going to look at y. Now, in short, just to say y, in short, is that in there are some expressions that when written, you cannot use you cannot use the trinomial expression on just to find your answer for x, because x is either a real number or an irrational number. We're gonna look at that. An irrational number is like one third. It doesn't have an end. It's actually 0.33333. It's just recurring, right? The square root of 2 is also an irrational number, right? Those are irrational numbers. 2 over 6 is also irrational, which is the same as one third. So that is the idea of irrational numbers. So 2x squared minus 7x equals 3. All right, let us look at this one. Now, if you look carefully in this one, we actually see that we have all the components to write it out like our general formula, or even before reaching the general formula as ax squared, well, in this case we could have minus bx, we could actually have plus c. Even if we add it written out like that, with c being right there, having this, we could, it's the same thing as if we had that and setting it back equal to 0. So we could actually write that out as that. So in other words, I'm saying that 2x squared, we're just going to bring this positive 3 over plus negative 7x. So this positive is going to come over. If we have to subtract it to remove it here. So here it's going to be 0, and over here it's going to be negative 3. So that's pretty much, our expression or our equation. All right, so just erasing all of that. All right, and I'm also going to write that up here so we can see what we're working at. And I'm going to try my best to stay to the left side of the board. Equals 0. So let us look at this now. I'm going to keep this part for now. So if I was to go ahead and solve my trinomial, I would say a times c. That's how we are taught. That's how it is done. So a times c. So a times c. So 2 times negative 3 is going to give me negative 6. Right? Now we have negative 6 here. And the factors of 6 is 1 and 6 and 2 and 3. Right? So we actually have that. And we said that in listing out the factors of 6, we have to get negative 6. So one has to be a positive and one has to be a negative when multiplying. So in other words, the only way to get a negative when multiplying is to have one of the numbers, one of the factors being a positive and the other being a negative. So either you have negative positive 1 and negative 6 or negative 1 and positive 6. You can't have positive 1 and positive 6 because positive 1 times positive 6 is just going to give me a positive 6, but it's a negative that is here. So that would throw an error. Here it is the same thing, one has to be a positive, one has to be a negative. Now, in establishing that factor, if this is positive 2 and this is negative 3, I'm going to end up with negative 1. And if I were to reverse that and say, all right, negative 2 and positive 3, I'm going to get a positive 1. Here, if I get a positive 1 minus 6, I'm actually going to get a negative 5. And if I have a negative 1 plus a 6, I'm actually going to get positive 5. So we are not going to be able to get our negative 7. And this is where the quadratic formula will have to step in, because we cannot use that way of solving our equation. So we have to go ahead and actually use our formula. X equals negative b plus or minus the square root of, b squared minus 4ac over 2a. As I said before, this formula is really an expansion of this formula right here. Right? So it's really an expansion of this formula. So this is literally this. All right, so let us now look at this that we have right here. Now we said before that this is a. Remember I just showed you that it's an expansion of our ax squared. So just remember that this is would be the c. So always consider your negatives. Always do that. So we have x equals negative. Our b would be negative 7. So we have that in bracket. Negative 7 plus or minus the square root of b squared. So b squared is negative 7 being squared. And then we have minus 4. A is actually 2. And here now, our c is negative 3. Always remember to keep back your negatives. If b is a negative, you remember that if it's a positive, you also remember. So that's 2 times a, and your a is actually positive 2. I'm literally still using the center of the board. But anyways, so I'm just going to stick here now more so to this side. So what we have right here is literally x equals negative and a negatives will give me a positive right there. So we have the square root now. The negative 7 squared is going to give me 49. This is going to minus negative 4 times 2 is a negative 8. Right? And the negative 8 times negative 3 is going to give me a positive value, which is going to give me positive 32. No, sorry, 24. So negative 4 times 2 is negative 8. Negative 8 times negative 3 is actually 24. So 2 twos is actually 4. So what do we have right here? So just going over to my right now. So we actually have x equals 7 plus or minus the square root of 49 plus 24. That's literally 63. Is there a number that is there a root of 63? Or is that an irrational? Is that irrational? So we have over 4, right? So that's what we have now. Now, in solving this further, we know that we're going to have x equals 7. We're going to have 1 being a plus and 60. What's the square root of 63? We can actually take our calculators to work that out. So the square root of 63 is going to give me, well, we can work with 7.94. Let's work with 7.94. 0.94, right, over 4. And for here, we also have x equals 7 minus 7.94 over 4. All right, so as I said before, is that you will get the idea that in most cases, well, not that I can think of any now, I don't think of there's any cases, that you'll find that your answer, one is a positive and one is a negative, right? So here we literally have 7 plus 7, 7 plus this is going to give me 14.94, and that divided by 4 is going to give me, so just add that and subtract it, add it and divide it rather by 4, going to give me 3.74. So either x equals 7.3.74 or x equals 7 minus 7.94 divided by 4. X equals negative 0.235. So that is literally how you do quadratic equations. It's really a simple breakdown that I actually went through, but this actually teaches you how to use your formula and also other quadratic expressions as I gave you with the difference of two squares. Those are also quadratics, and those you saw how I actually handled those in solving. Just remember the equations are the ones with your equal sign, and then you're going to actually solve for x. X always have two possible values when you're doing quadratics, either one being positive, one being a negative. And trinomials, there are some expressions with three terms that you have to just use the general formula. This is the general formula of solving quadratics. All right. So thank you very much for tuning in, and please remember to like, share, and subscribe to this channel. And also, you will in the description you will also get a link where you can purchase my books. All right. So again, thank you very much, and we will be back again with other topics on on different weeks. We'll have different topics teaching you about high school mathematics. Thank you very much, and until then, take care.